All right, guys, this is section 4.4 and 4.5 together. This is triangle congruence shortcuts. So what we're going to do here is we're going to prove triangles congruent. So let's review. We've got triangle MNG, and it's congruent to triangle EFO. And so we need to determine some corresponding parts. So back in chapter 1, you identified congruent triangles, congruent polygons. You did different congruent figures, and then we had talked about how every part has to be correspondingly congruent. Okay, so one way to look at it is the way up here, the way these are listed in order. Okay, the M is going to be congruent to the E, meaning angle M is congruent to E, and N is with F, and G is with O. Okay, so you can look at it that way, and that's how you need to focus on what is congruent. And then of course you can look at the segments as well. You can also mark the two figures congruent over here. So we have, we said M is congruent to E, so you could actually mark that if you want to, and you can even color coordinate it. Okay, it also said N is congruent to F, okay, because that's the second one listed. Okay, you can do 2 tick marks there. And then it also says G is to O. Okay, so we have all of those angles being congruent, and therefore the sides are going to correspond together also. So like between the red and the blue, MN, that's going to be congruent to that side right there. And you can also check over here, MN is congruent to EF. Between the blue and the green, those two sides would be congruent. Between the red and the green, those two sides would be congruent. And again, it's listed in order over here. And so once you mark that figure, it should be pretty easy to write down what angle is congruent to what and what side's congruent to what. So M is to E, angle G is to angle O, and angle N is to angle F. Over here for the segments, MG, which is the first and last letter, that would be EO. Okay, or you can look at how you marked your triangle up. NG is down here, the 2 tick marks. That's going to be congruent to FO. And then MN is the 1 tick mark, and so 1 over here is FE. Okay, so you got to work with corresponding parts also. You got to know which one is corresponding to which whenever you're referring to congruent triangles. Some other terminology that you need to know, these words called included side and an included angle. That's another way to say it, the angle or the side in between. So if we're looking at the included side of angle X and angle Y, here's angle X and here's angle Y, the included side would be the one between those two angles, which is pretty simple, XY. And then over here, the included angle of side XZ, which is this one right here, and side YZ, which is this side right here. So the angle between those two sides is angle Z, okay, which is right there. So it's between. So that's the other way to, whenever they use the words included, which you're going to see on the next page, that just basically means the one in between what is given, okay? So know about corresponding parts and know about the included angle and the included side. So what I'm going to go over next is the 5 conjectures that proves triangles congruent, okay? So this is what proves triangles congruent. So we're going to pay attention to these these conditional statements right here. And we're going to have to use these in order to see if 2 triangles are congruent. So this first one's called the SSS congruence conjecture. And so if 3 sides of one triangle are congruent to the 3 sides of another triangle, then the triangles are congruent. Okay, so you can see a picture here, and it's showing that all 3 sides here are the same as these 3 sides over here. So these 2 triangles right here are congruent. So triangle A, BC. So let's write it out. Triangle ABC is congruent to, and we got to again put these in corresponding order. So I went A to B to C. So that's the 2 tick marks. And then, so 2 to 1, so that's X, Y, Z. So luckily it was in alpha order, so that one was easy. It's not always in alphabetical order. Okay, over here, side angle side. This one, sorry, SAS, which now you have figured out that it represents the side and the angle inside, which I need to go back to this one. The SSS stands for side, side, side. Okay, because we wrote down in the conjecture the 3 sides. Okay, and so SAS actually represents the side, the angle, and the side being congruent. So let's fill out the conjecture. If 2 sides and the included, there's that word included, okay? So included angle of one triangle are congruent to 2 sides, and the included angle of another triangle, then the triangles are congruent. Okay, so right here we have a picture of these 2 sides. You see the 1 tick mark and the 2, and they're congruent to these 2 sides over here. And then the included angle, you see this arc in between these 2 sides. These two angles are congruent. So you can kind of also see it in a pattern like side, angle, side. This side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. Okay, so you have this next conjecture. If you see 2 triangles, and then these 2 sides are congruent to these 2 sides, and the angle in between is congruent to that angle in between, then you now have to know that those 2 triangles are congruent. Okay, let's go to this next one. Angle, side, angle, congruence conjecture, ASA. So if 2 angles, that's what goes in the first blank, and the included side, there's the word included again, of one triangle are congruent to 2 angles, and the included side of another triangle, then the triangles are congruent. Okay, so there's 3 different ways so far that we've talked about that if you see this little pattern, the triangles have to be congruent, okay, because it's already been proven. So here it is, angle to this angle, this side to this side, and this angle to this angle, okay? And so again, I forgot to write these up here, but this one over here, this triangle ABC, is congruent to triangle, let's make sure it's in alpha order, A, B, C. So this one actually is not A, B, C. So the A is this unknown side, okay, it's just blank. B to the C is the 1 tick mark, okay, so we're going to go unknown side, okay. Actually, it is in the same order. I don't know why I thought it was not. So X to the Y to the Z, okay. So again, in alpha order here. Now, they're not always in alpha order, but perhaps on this one. Okay, and this next one, going back to angle, side, angle, okay, we're going to say triangle. Let's stick to ABC and see if it's still in alpha order. A to the B to the C. So the 2 marks on the angle, 1 and 1, X, Y, Z. Yes, it ends up being in alpha order again. X, Y, and Z. All right, let's look at this next one, SAA. I'm pretty sure you can tell what that's going to stand for. A side angle angle pattern, okay, congruence conjecture. So if 2 angles and a non-included side, notice this is not going to be in between the 2 congruent angles. So non-included side of one triangle are congruent to the corresponding 2 angles, and again, non-included side of another triangle, then the triangles are congruent. Okay, so look at this pattern over here. Look, angle, angle, side. Same thing over here, angle, angle, and side. Okay, angle, angle, side. So these two angles are congruent here. Actually, this is not a good picture now that I think about it. Okay, let's go ahead and fix this. You should have two marks right here because this one has two marks next to this side. And then this one should be erased. Let me get the white pen. So this is the way it should look. Okay, so 1, 2, and then a side, 1, 2, and then a side. Okay, trying to be careful with that. I don't know why that's marked that way. Okay, so it has to be in that particular pattern. Angle, angle, side. So see, this angle is congruent to this angle. The very next angle is congruent to that very next angle. And this side is congruent to that side right there. So there's the pattern, angle, angle, side, angle, angle, side. And if you happen to say it backwards, that's fine too. Side, angle, angle, side, angle, angle. So let's see how these triangles are congruent. So we have triangle. Let's see, let's go in KLM. Oops. And that's congruent to triangle. So let's go in order, K to the L to the M. So 2 to 1. So that's going to be SUT. So no particular alpha order on this one, but you got to make sure they are corresponding, okay? And so that was a little typo on here, so make sure you mark those up correctly. Okay, and then over here, the last one, this one's called the HL congruence conjecture. So no S's and or A's. So HL is going to be a little bit different. Okay, so you're going to have to remember your terms from a right triangle. So it says if a leg is going to go on that first blank, and the hypotenuse, remember the word hypotenuse from a right triangle, of a right triangle, because those are the only terms that exist in a right triangle. If those two are congruent to the corresponding leg and hypotenuse of another right triangle, then the triangles are congruent. Okay, so you'll notice in this picture down here, say this is a leg right here, showing those two legs are congruent, and then this hypotenuse with the two tick marks, those two are congruent. And then of course you have your right angles to show that they are right triangles, okay? So for this last one, let's write it out. Triangle ABC is congruent to, let's make sure we write it in order, A to the B to the C. So A is at the right angle, so X has to go first. B is the one tick mark, Y, Z. So it happens to be an alpha order on this one as well. Okay, so these are the 5 conjectures that proves triangles congruent. Okay, so you're gonna have to have these by your side when you're doing your homework. So that's the SSS conjecture, SAS, ASA, sorry, SAS, ASA, SAA. Now again, don't forget, some people accidentally write these backwards, and that's okay. AAS, and the last one is HL. H stands for hypotenuse, L stands for leg. Okay, so how do we use these conjectures? Okay, so these conjectures are used in a problem in which they're asking if the triangles are congruent. So basically, it says, if possible, name a triangle congruent to a given triangle, and then it says state the congruence conjecture. If you cannot show the triangles to be congruent from any information given, right cannot be determined, and explain why. So let's take a look at this first picture. So I have this side congruent to this side, meaning the one tick mark and the one. I have this angle, which is 30 degrees, congruent to this angle. And then I have this side congruent to this side, 2 tick marks and 2 tick marks. So SAS, SAS. So that should sound familiar. That's the side angle side conjecture. So we know these are going to be congruent by side angle side. So now it's a matter of writing them in corresponding order correctly. Okay, so over here, I'm going to just say TCO for this bottom one. You can start the first one however you want. T to C and O. So T goes on the one side tick mark to the 30 degree and then the 2. So this one's going to be ANP. Okay, so if you don't write them in order, then it's not going to be correct. All right, let's check this next one out. I see this angle congruent to this angle, so I'm going to write a little A there. Sometimes this helps. You don't have to write SA or anything if you don't want to. I have this side, which is 15 congruent to this side, and that's it. Okay, actually, however, you have to now know that you know about vertical angles, so you can actually mark those equal yourself. They're not going to mark them for you. And so this angle is congruent to this angle. So look at that pattern. This angle, side, and angle are congruent to this angle, this side, and this angle. So that's part of our list. So we're going to write that down, ASA. And then now we need to write the angles and the triangles in order. So we've got, let's just start with S at the 64. So I'm going to write S first, and then I'm going to go to E and then C. So S, E, C, triangle S, E, C. I'm going to start at the 64, N, E, B, because I went to the 15 and then the vertical angle. So N, E, B. All right, so those two triangles are congruent, okay? And then remember, sometimes they're not congruent, sometimes they are. So it just so happens these two have a pattern in which falls under one of the 5 conjectures that we just talked about. Okay, let's take a look at this next one. This next one's tough because nothing's really marked. But you do know that this side is parallel to this side, okay? And remember, none of these are ever drawn to scale. So if these two are parallel, then you should know that this angle is equal to this angle. Those are alternate interior angles. Nothing else is equal, okay? Now here's another thing. This side is actually the shared side for both triangles. So like if you were to draw these separately, you can say that FS is congruent to FS by the reflexive property, okay? Because it's its own side, all right? And that's really all I know. I don't have any other information. Now, some of y'all are probably thinking, well, this side has to be congruent to this side. No, it does not, okay? It can be, but it doesn't necessarily have to be, okay? It looks like it is, but there's no proof that it is. So what I like to do sometimes is I like to redraw these to scale, okay? So for instance, all I know is that the top side and the bottom side are parallel, okay? So I'm actually, it doesn't say they're the same size. So I'm actually going to draw the top one smaller and the bottom one longer, okay? And then I'm going to connect here and I'm going to connect here, okay? And then I'm going to still draw that diagonal in there. So now look, when I draw it like this, these are still parallel, right? This angle right here is still congruent to this angle because those are alternate interior angles. However, nothing else is congruent here. So let me label these again. This one was point A, this one is F, this one is S up here, and this one is T, okay? So when you look at these are not congruent. Look at how much smaller this triangle is over here compared to this triangle over here. Okay, so the only parts that you know is these alternate interior angles are equal. Now it looked, they made everything look congruent, but it wasn't, okay? So sometimes we need to draw it to scale, okay? Kind of like when we studied quadrilaterals at one time. So since we don't have enough information about anything else, here's what you write. You write cannot be determined. Okay, cannot be determined. So you don't write that the triangles are congruent, and there's obviously no reason. Okay, so that one was a tough one. So sometimes you have to redraw it to scale. Okay, so now we're going to actually turn it into a proof. So how does it look as a proof whenever you're writing this out? You're going to list all the given information, so whatever they may have given us. Reach any conclusions to make sure that maybe there's vertical angles congruent, maybe there's other congruent parts. Okay? Look for reflexive or just congruent parts in general. Once you have 3 statements, you can conclude that the triangles are congruent by one of those 5 reasons that we have listed on our paper. So let's do that on this proof right here. Okay, so it's going to be a statement, reason, proof. And you kind of saw this a little bit when we did a deductive proof. So this is kind of the same thing. So the first one I listed for you, it says angle ACP is congruent to angle OPC. Okay, and that is given. Okay, the other thing I notice is that this side is congruent to this side. So we're going to say AC is congruent to PO. Okay, and we're going to write given because they marked it for us. Okay, now there's nothing else showing congruent, but you should mark this yourself. So PC is actually congruent to itself. Okay, you can reverse the letters if you want, doesn't matter, same thing. And this is called the reflexive property. Whenever you're saying something is congruent to itself, that's what you want to write, reflexive property. Okay, you can just write reflexive, that'll be fine. So now we have 3 parts. Now let's look at the pattern here. Side, angle, side, side, angle, and side. So we know the reason's going to be side, angle, side. Now we just have to put the triangles in corresponding order. Okay, so over here on the left, I'll do this one over here. I'm going to do ACP. ACP is congruent to triangle. So look at the pattern how I went. Make sure it's in corresponding. From A over here, one-sided to the 2 tick mark angle, and then the inside. So that's going to be OPC. Okay, so that's how you do a proof. Over here in this one, let's try it again. I have these 2 triangles. I have some congruent angles that I see. They have a shared side, so let's go ahead and get used to marking that side congruent to itself. It's always good to put those markings out there. Okay, so what do I have here as far as a pattern goes? Okay, I have this angle, this side, and this angle. So look at that pattern, angle, this side, and this angle. Do I have that same pattern here? Angle, this side, it skips over this angle here and jumps to the next one. Can we say that that's consecutive? No, it's not. And in this case, when we go back to our conjectures, all of these were consecutive. So like, look at this one, side, angle, side. See how all 3 were consecutive? I failed to mention that earlier, so make sure you remember that. They're all consecutive. Remember, consecutive means one right after the other. So see, they don't skip over any angles. So these are all consecutive for angle, side, angle. Okay, that's the main one we need to look at. So this one right here does not necessarily look like this one here. So this one is consecutive, but then this one over here, it's not. Okay, so you really don't need to have a proof written out. Okay, you can write some things down. You can say that angle MOW is congruent to TWO. Okay, that's given. So you can write these givens down, but in the end, it doesn't match up with each particular triangle. This one pattern over here is in the form of angle, side, angle, and this one over here is in the form of angle, angle, side. So when you have 2 different patterns, then these 2 triangles are not congruent, okay? So you really don't need to write anything here. You just need to write cannot be determined, okay? Cannot be determined. We need to know probably some other measures in there in order to figure this one out. So no need to write a proof, just write cannot be determined, okay? And it's because of these 2 reasons right here. They're 2 different patterns here. So that's how you write proofs out. They're gonna look like that, okay? So be able to write that out. And you'll notice the first 3 are your 3 patterns, okay? So usually I like to write them in the order of, you know, side, angle, side. This one happens to be angle, side, side. Okay, yeah, don't say that. And then this one over here, well, it wasn't congruent, so we don't need to write that anything down. Okay, the last problem of the day, this one's going to be constructing congruent triangles, which you have a little bit of knowledge on this, so this one should be pretty easy. So it says use the side angle side congruence conjecture to construct a second triangle that is congruent to this given triangle. Label it XYZ. Okay, so you want to pick out the side, the angle, and the side that you want to copy, okay? So I'm just going to pick out this side, and then I'll copy this angle, and then I'm going to copy that side, just so you have a little plan going, okay? And I want to kind of make it look like that one. So my first side that I want to copy is that one right there. So I'm going to draw a long line. And so I'm going to copy AB. So you're going to put your compass on here. You're going to go get the width of AB. I'm going to place it up here. And I'm going to make an arc. Okay, so that side is congruent to that side so far. So I'm actually going to put a tick mark there. That side is congruent to that side. Now I want to copy this angle down here. Okay, so I'm going to come over here. You know how to copy an angle. I can get my compass to work. So I'm going to place my compass over here. And I'm going to copy this angle here. So my first step is to make an arc on the angle. Make that same arc over here of where I want to copy the angle at. Now I'm going to go measure how wide the angle is. Place it on this intersection right here and make an arc like that. So I just made an angle the exact same size as angle B right here. And line your ruler up exactly with that. All right, so far now I just made, let me get a different color, let's do orange. This angle is congruent to this angle because I just constructed it, okay? And then the last thing I need to do, I said I was going to copy this side now, okay? So I already have that side drawn. So now I'm going to go measure how long that side is. Place it on B. Get the width of that. Place it over here and make one last arc right there. Okay, so now all I have to do is connect my starting point that was over here to that last final arc. And then so you can see I copied that, or I copied this side to this side. I copied this orange angle to this orange angle down here. And then now, let me get a different color, let's do purple. I just copied this side to this side over here because of that arc right there. And so there it is in that pattern, side, angle, side, side, angle, side. One last thing it said to do was label it XYZ. So A, B, C, I'll keep it X. I'll say this one is Y and this one is Z. So I just made a triangle exactly the same size as that one by the SAS congruence conjecture. All right, guys, that's it.